hazardous area awareness concentration. An area is extent and classification study involve a due consideration of one of these following consideration of a flammable material that may be present. One of it is a flammable materials which need to be considered around that vicinity. And for considering these flammable materials, the second is also for you to consider the hazardous area awareness of a certain area, the concentration of a certain area. You also consider the physical property and the characteristics of such flammable materials. Let's take, for instance, acetylene, let's say a thinner or a PMS. The physical property of it might be flash point of 20 degrees centigrade, or a boiling point of 56 degrees centigrade, or a vapor pressure of 180, a vapor density of 2, and also an auto ignition temperature of 465. Maybe a flammable range of 2.6%. And because this thinner or acetylene or PMS has a low flash point and high vapor pressure, it evaporates quickly and can form a flammable mixture in air. Even at a room temperature, its vapor can settle near the floor, meaning down, and ignite from the distance as it senses a source of ignition, which is spark, making a proper storage and ventilation essential for every facility. Another point to consider in this hazardous area awareness concentration is the source of potential release. The source of potential release. And this means that a source of potential release is a point of location or equipment where a flammable gas vapor or liquid could escape into the atmosphere, either during a normal operation due to a fault. This release could lead to a formation of flammable explosive atmosphere, depending on the concentration and the surrounding condition. Why? This concept is central to hazardous area classification under the IEC code of 6079/10/1, like I rightly quoted earlier, which help to determine the extent of the risk and a guide of the safe installation of electrical and mechanical equipment. Let's take, for example, we have a valve on a fuel transfer line at a petroleum, let's say petroleum depot. During a normal operation, the valve may leak small amount of a fuel vapor when open or closed. This valve is therefore a source of potential release because it can emit a flammable vapor into the into the surrounding. Based on the frequency and the volume of the release, this area may be classified as zone 1. And if it's likely during normal operation, then it will now be classified as zone 2. If the release is infrequent and short-lived. So now, for example, let's take, for example, as a similar thing that normally occur in a depot, a sampling point on either a chemical line or a product line, where an operator collects product sample. Even if it's tightly sealed, each time it opens, there is a chance of vapor escape. making it a source of potential what? Release. That is a clear example. In hazardous area awareness concentration, we can also consider a factor which is known as prevailing operating temperature and pressure. This means that the typical or most frequent observed temperature at which a system, equipment, or a process operator under a normal condition is not necessarily maximum or minimum temperature, but rather a steady state of temperature at the system maintaining during a regular operation. What does it mean? That the value of a crucial engineering design or safety assessment, especially when evaluating a material of compatibility during design, a thermal expression during design, the risk of ignition of flammable substance during the design, or the equipment selection and installation requirement during what? Installation. For example, let's say you are working with a natural gas compressor in a process plant. During a normal operation, the compressor casing constantly reaches 65 degrees. Although it may spark to 80 degrees during a startup or a drop to 40 degrees during a shutdown, but we are going to pick 65 degrees as a prevailing operating temperature. And this temperature is used to assess whether the nearby flammable gas could ignite or whether insulation is needed or whether an equipment complies with thermal safety standard. For example, let's assume that a chemical reactor, the process may involve maybe heating a reactant to like 120 degrees. And if the temperature is maintained for most of the reactor cycle, it becomes a prevailing operating temperature used for selecting seal or gas in a control system. So it is a very important point to note in hazardous area awareness in concentration. Another point to note is the presence and the degree and availability of ventilation. What it means is that these two key words, which is the presence of the degree and the availability of ventilation, is a factor of hazardous area classification. Let's say a presence of degree. What it means is that it's related to the grade of release of how often and how much flammable materials are expected to release during a normal operation. It's categorized as a continuous release. If it is a continuous release which occurs frequently or constantly, or primarily a primary release, which is a release that occurs occasionally during a normal operation, or availability of ventilation, which refers to an effective movement and dilute or disperse of flammable vapor, reducing the risk of ignition ventilation. So therefore, if it is a high ventilation, it is rapid dilute vapor, reducing a hazardous zone size. If it is medium ventilation, it's a moderate dilution, smooth risk remaining. If it is a low ventilation, it's a vapor vapor will linger and increase the size and severity of hazardous zone. I want to cite an example for a better understanding. Let's take, for instance, imagine a fuel dispensing a pump at a petrol station. I think that is a good example. The grade of release is every time fuel is dispensed. The vapor are released. This is a primary grade of release because it happened regularly during what? An operation. Now, let's consider the ventilation aspect. The pump is located outdoor where the natural ventilation is what? High to open air and wind, because the frequency of the release and the good ventilation, this area immediately around the nozzle may classify as what? Zone 1. While the surrounding area may be what? Zone 2, even non-hazardous, depending on the vapor dispensed. I want us to also consider one of the factors which will be considered during a hazardous area awareness concentration, which is the probability of each release. The probability of each release. I want you to understand that the probability of release refers to the likelihood of a frequent that flammable substance will be released into the atmosphere from a particular source during normal operation. Under a fault condition, it can help determine how hazardous area or what a safety measure are required. In a hazardous area classification, just like rightly said, the concept is used to determine the grade of release, which is categorized according to IEC 679/10/1. And this design is to consider the continuous happening, which is known as a frequent happening, primary, which is happening occasionally, secondary, which is happening rarely. For example, let's say you have a gas sampling point on a pipeline. And this gas sampling point, if the sampling point is automated and operates continuously, then the release is a small amount of gas regularly. Then probability of release is what? Is high. Because it is a continuous release, and which makes that area a zone 0. If it's used once or twice a day during a routine check, then the probability of release of that gas sampling point is moderate, which is a primary release, and it can be considered at that area as zone 1. Then if this gas sampling point, if it is used only during maintenance, let's say for instance, monthly, the probability is low and is regarded as what? Secondary what? Release. And it's known as that area is regarded as what? Zone what? 2. I want you to share this video so that others can gain knowledge. And don't forget to watch out for another section of this hazardous area awareness and equipment classification. Thank you.